This meeting is being recorded. All right, in this video, we're going to look at the first part of the second objective, which is on the normal distribution. And there's three values that will definitely be given to you on the test, the 99.7, the 95, and the 68. The way to remember this is that 68% of your data is going to be within one standard deviation away from the mean. And so if we look at this first problem, we've got the mean at 495, which is directly in the center there. So this is our mean. And if I go one standard deviation away, that means that this region, up until these 2 points, is going to be 68% of your data. Similarly, if we go 2 standard deviations away from the mean, so 1 standard deviation and 2 lands me here, in both directions lands me here. So this region covers 95%, and then the last little one going all the way, well, it looks like it's almost all the way, but it's not quite. It's 0.3 data is still remaining outside of those two, but this is the 99.7. So how we can use some of this data is with subtraction, because if we know 100% of the data, it lies under the entire curve, then I can find the remaining part. Because if I take 100% and subtract out what is shaded right now, the 68, that leaves me with 32%. And so that tells me that both of these regions added together will create 32. And therefore, just this region will be 32 over 2, or 16%. And that's what the first question is asking for. What percent of the total scores are between 495 and 611? Nope, that's not the first question. That was the second question. So if we look at this first question, it's asking between 495 and 611. And so that's a fairly simple one, because if we look at the data between 495 and 611, is this half? And so if the whole thing is 68, then I can just divide that by 2 and get 34% of the data falls between those two values. So the second question, students who scored in the 16th percentile or below wanted to retake the test, shade in the area of the distribution in the picture above. So as I calculated previously, both of these regions are 16%, so that means they would have to score less than 379, less than a score of 379. If a total of 100,000 students took the test, how many of the students scored 727 or more? So 727 is right here. So if I'm looking for this little value, that means that I'm going 2 standard deviations away, which means I'm looking at the 95%. So if it's 95% for both of these little regions, then I can take 95 from 100 and get 5%. But they're asking me of this total. So 5%. 5% is the total, so we need to divide by 2. So 2.5% of 100,000. So in your calculator, you can type in 2.5 divided by 100, because that is 2.5%, and then times that amount. And so that's how we get 2,500. Of 2,500. I'm going to triple check that now because I'm feeling self-conscious. Let's see. So that would be over the 100 times 2.5. Yep. 2,500. So we're multiplying by that value, and that'll get us the 2,500. The retake of the SAT was much different from the first time. This time, there was a mean score of 510, a standard deviation of 70, sketch the normal distribution curve, and label your axes, provide tick marks. So when we look at this, the value along here is going to be our score that we have. So if I place the mean in the middle, that is the 510. And every time that I go above, that means that I'm adding a standard deviation. So that's adding 70 to 510, which will get me to 580. Adding another 70 will get me to 650. And then I've run out of space, so I need to extend this a bit more. Which means that that whole thing won't fit. So let's move that whole thing over. There we go. And then moving it, we've got, hold on. There we go. That's right. All right, so then this is ready. Adding another 70 is 720. So these are my little tick marks going along to the right, and then I can do the same exact thing going to the left by subtracting 70 each time. So that'll be 440, and then subtracting another 70 leaves me with 370 and down to 300. So again, we've got the other tick marks. So if my center is perfectly balanced right here, that means that the curve will look something like this. Sorry, I'm subbing for a science class. What is the probability that a randomly selected test from the pre-tape will be above 650 or below 370? So above, let's do a different color. Above 650 would be 2 standard deviations away. So I knew that back in the previous problems, 2 standard deviations away is 95. So that means that this is 2.5%. And then below 370, same thing. So that's 2 standard deviations away. So that means that this is also 2.5. So that means that we are looking at 5% of the probability. I'm going to come back in a separate video and do this second part.